Hi guys, this is Dr. B. This is a lecture video on balancing equations, reactions if you still are struggling. So, in order to do that, you need to be considerate of the law of conservation of mass, which states that on both sides of this arrow, the masses for your reactants should equal the product somehow. Additionally, whatever element you have on the reactant side and how much you have of it, you should have the same on the product side as well. So let's do a couple of these together so we can make sure we understand. So let's use our acronym MINHO. So it's metals, ions, nonmetals, hydrogens, oxygens, if you're uncertain how to balance this. So there are no circles, no balls, no molecules, like looking at the little models. You have to be able to do it without it. So I'll start off with P2O5 plus H2O produces H3PO4. So I have two P's on my reactant side and only one P on the product side. So I'm going to put a 2 in front of here. And what that does is that now we'll distribute to the H3, the P, and the O4. When I say distribute, that means multiply. So I have two P's here. I have two P's here. But after doing that, it changes how many H's I have, how many hydrogens I have. So remember that it's distributing. I have 2 times 3 H's, which equals 6. So on the other side, on my reactant side, I only have 2 that I'm highlighting in blue. So that means I need to multiply some number by 2 to ensure that I have the same amount of H's on both sides. So right now, I'm going to put a 3 in the front. So 3 times 2 equals 6. There are 6 H's on both sides. All I have left now is just the hydrogen, or the oxygen. Sorry. So I got to do my math to ensure that I have enough of each. So let's look at our reactant side over here. For now, I will have 1 times 5 oxygens from this reactant plus 3 times 1, because the 3 distributes in. That will equal 8 oxygens. Now look over here, I have 2 times 4 oxygens, so that equals 8 also. So that means right now I am balanced for this reaction. Also, just a quick review, this is a synthesis or combination reaction. Okay, so the next one I'm looking at is the one on the bottom. C6H12 plus O2 makes CO2 and H2O. So this reaction is called a combustion reaction, and it's a type of reaction that needs energy to kind of begin, for it to kind of go, for it to go forward, so to speak. So let's use our MINHO to balance this. I look, do I have any metals? No, I don't. Do I have any ions? So ion is like nitrate, phosphate, sulfate, sulfite. Do I have anything like that? No, I don't. So do I have any nonmetals that are not hydrogen or oxygen? I do. I have carbons. So I'm going to focus on my carbons first. So I have 6 carbons on the reactant side, and on the product side, I only have 1 from the CO2. So I need to put a 6 in front of the C right here. That will change my number of carbons there. So now they're both equal. I have 6 and 6 on both sides. Let's focus on our H's. I have 12 H's on my reactant side. On my product side, I have 2. So what times 2 will equal 12 to give me the correct amount of oxygens? So you got to do some mental math, potentially. So 6 times 2 equals 12. So I put a 6 here. So as I'm looking at this, right now I have one C6H12, I have six CO2s, and six H2Os. So I will use those to determine my number of O2s on that O2, the O's on the O2. So I have 6 times 2 is 12. I have 6 times 1, that is 6. So 12 plus 6 is 18. What times 2 will give me 18, and that will be my coefficient. So I'm going to put a 9 in the front here because 9 times 2 is 18. And that is kind of, I want to double check, but it looks like everything is now balanced. So we balanced this combustion reaction right here. So let's look at these three now. We have a double displacement, a single displacement, a reaction here. The one on the bottom, we won't focus on what type it is, just making sure we have one reactant and multiple products, so this is a decomposition reaction. So let's use our mine hoe to balance. So I look at my metals. I have two metals. I have sodium and calcium. And it looks like those are all in a 1-to-1 ratio as of right now. So I'm okay with it. So let's look at our ions. I recognize I have a hydroxide ion of 2. So I have 2 OHs. Over here I only have 1 OH. So I have to recognize the pattern of the OH is a hydroxide ion. Since I only have 1, I need to put a 2 in the front right here. And what that means is that now it changes my number of sodium ions on the product side. I have 2. On the reactant side, I only have 1. So I'm going to put a 2 in the front here because 2 times 1 equals 2. So I look over here, how many, notice it changes now my BRs. This 2 distributes to the 1 BR. So now I have 2 on the reactant side. I go to my product side. I see I also have 2. So that's a good thing. Then I see my calciums. Well, they're still 1 and 1. So that is my balanced reaction. So let's look at the next one. This is a single displacement reaction. So let's look at our mine hoe. So metals, I have lead only. That's my only metal. I do have ions, so that's good. So let's focus on the lead first. I have 1 PB here. I have 3 PBs here. So I want to put a 3 in the front to take care of that. So good. Ions. I have a phosphate ion here and here as well. According to this, I have 2 PO4s. Here, I only have 1 PO4. So I'm going to put a 2 in the front of my reactant here. Now that means I have 2 PO4s. I have now 6 H's right here. Make it a different color. Because 2 times 3 is 6. On the product side, I only have 2. So I want to put a 3 in the front to balance that. I still have 3 leads and my 2 PO4, so now this one is a 1. That's my final coefficients for this reaction. Let's look at our decomposition on the bottom. Looks like I have lead 2 nitrate. So let's see what we're going to do with that. So let's do our mine hoe. So I have lead. I have 1 lead on each side, so that's good. I have an ion right here in NO3, but I don't really see an NO3 pattern here, so I can't do that. So let's try doing this. So I'm going to, remember that whenever you have parentheses like this, I'm going to change the color for this one. This number outside distributes to this number and this number right here, or to that element, I'm sorry. So technically, I have two nitrogens on this reactant and six oxygens here. Okay, so we haven't really done this part yet, so we're going to work on this together. So I have two nitrogens because the two distributes to what's inside of parentheses. So I will put a 2 in the front over here, and I have 6 oxygens to work with. So let's see. I have 2 right here, I have 4 right here, and I have 1. All right. If I look at my product side, I have a total of 2 plus 4 plus 1. So that right now I have 7 oxygens here. So that's not going to work out too well for now. So maybe we can kind of figure out what we can kind of manipulate easily. We haven't looked at the lead in a while, so let's look at that. So it's kind of trial and error now. So if I change my lead to 2, and I'll put a 2 over here as well for my product, lead 2 oxide. That changes my lead, so let's see how that affects my oxygen. So I'm going to use a different color so we can clearly see it. So on this reactant, I have 2 times 3 times 2, and that is going to be 12 oxygens. All right. Also, I may have jumped the gun a little bit, but notice how now we have 2 times 2 nitrogen. So now I technically have 4 nitrogens on this reactant. So I'm going to change this over here to a 4. So let's see if that will affect our number of oxygens now. So technically I still have 12 in this reactant. So I got 2 times 1 for now, plus 4 times 2, which is 8, plus 2 times 1. So it looks like I have 8 plus 2 plus 2. Oh, that equals 12. So that means that I am now balanced. My coefficients are 2, 1, 4, 2, 2, 1, 4, 2 for this particular reaction. All right? So that is it for now. If you have any questions, please let me know. Thanks.